welcome to the module on pedagogical content knowledge in physics. And you are once again welcome to Unit 1 of this module. And in Session 2 of this unit, we will be looking at content knowledge. My name is Patrick Ejay. Now, after going through this session, you should be able to explain content knowledge. Then state and explain the components of content knowledge in physics. So let's look at content knowledge. And basically, when we say content, we are referring to the content in the physics syllabus or in the physics curriculum. And so content knowledge will basically means your knowledge about the various contents in the physics syllabus. So content knowledge, or in short CK, is the teacher's knowledge about the subject matter to be learned or taught. And the teacher should have broad and current understanding of the major content areas of physics. So you as a teacher, you must know more than what your students know. And so you must have a broader understanding of the various components of the subject matter physics. And this includes areas such as mechanics. So we know that physics, we have mechanics, we have electricity, we have heat, we have waves. As a physics teacher, you must have a wide knowledge base in all these topical areas in the physics syllabus. So this knowledge in general includes knowledge of concepts, knowledge of theories, ideas, organizational frameworks, knowledge of evidence and proof, as well as established practices and approaches towards developing such a knowledge. And in the case of physics, content knowledge is the knowledge of the physics discipline itself. And this knowledge includes factual knowledge, conceptual knowledge, and procedural knowledge. Now, in the subsequent slides, we will be looking at these kinds of knowledge in detail. So let's look at factual knowledge. And as the first four letters of the word factual suggest, it talks about facts. So this consists of facts and ideas of physics. And it consists of the basic elements the teacher must know and must be acquainted with the physics discipline or solve problems. So the basic knowledge in physics that you as a teacher, you must be abreast with so that you can solve basic problems in physics as a discipline. And it includes knowledge of terminology and knowledge of specific details and elements. So for example, we know that electrons are negatively charged particles. This is a basic knowledge. Like charges repel. Heat flows from a warmer region to a colder region. Basic definitions, unit of mass. All these are basic facts that you as a physics teacher, you must be abreast with. And your knowledge about these basic facts are termed as factual knowledge. Now let's look at conceptual knowledge. And this knowledge describes the interrelationships among basic elements within a larger structure that enable them to function together. So your knowledge about the various concepts in physics, and it consists of the ability of the physics teacher to explain physical phenomena and understand qualitatively without the use of formula or equations. So your ability to understand basic phenomena in science, in physics, your ability to understand various applications of some of the topics or content in the physics syllabus. And it includes knowledge of classifications and categories, knowledge of principles and generalizations, as well as knowledge of theories, models, and structures. So an example of conceptual knowledge is that you as a physics teacher, you should be able to understand and explain the conceptual knowledge in physics. So example like density, and we will define density as the mass per unit volume. And when you teach a learner that density is the mass per unit volume of an object or of a substance, by implementing can state an example that it is this mass per unit volume of a substance that will determine whether an object will float or sink in liquids. Now let's look at procedural knowledge. And as the name suggests, the procedure. And so this knowledge describes how to do something, methods of inquiry, and criteria for using a skill, algorithms, techniques, and methods. And it consists of methods of investigation in a physical phenomenon. So procedures differ from concepts. And how do they differ? We know that procedure talks about rules that specify how to solve a problem. So anytime we talk about procedural knowledge, then it is the teacher's knowledge about the various rules that governs how to solve a particular problem in physics. And they are like recipes in that they specify the concrete steps that have to be executed in order to reach a goal. And good procedures can, for example, enable students efficiently solve quadratic equations, or it can help them to efficiently construct a toy ship which will actually float on water. So after taking students through the concept of density, and they know that once we have two substances and one is heavier than the other, then chances of the less dense object floating on the denser one is very high. Learners can create an object such as a toy ship which will be relatively heavier or relatively less dense than water or than any other liquid. And once they drop this object on water, since its density is less dense than that of water, then it is likely to float. But students can only do this when they know the procedure, when they know the steps that they have to take in order to construct this toy ship or this object that can float on the surface of water. And this can also help students to know the criteria that is used to determine when to apply a procedure involving Newton's second law of motion. And basically, we know that the second law of motion is what will lead us to derive the force relation. That's the relationship between force acting on a body and the body's mass and acceleration. It is through procedural knowledge that we can guide the learner to know when to apply this second law to solve problems. Students, we have looked at content knowledge, and we said content knowledge talks about you, the physics teacher, your knowledge about the subject matter of physics. And this knowledge we looked has some components, and the components are factual knowledge, conceptual knowledge, and procedural knowledge.